Hi everybody, good afternoon. Welcome to the Living Windfarms Project Workshop, the Contractor Perspective. I'm just going to allow a couple more minutes for anyone else who's trying to join now to dial in, and then we will get started. Okay, we've had a few more people join, so I'll make a start. Can I just double check that everybody can see my screen and hear me okay?
Yes.
Yes, we can hear you perfectly.
Perfect. Okay. So welcome everybody to the Living Wind Farms Project Workshop, the Contractor Perspective. My name is Jack Catamol. I am Operations Manager here at Exo Engineering. Just to make you all aware as well, this session is being recorded, so we will send the links out to those who have signed up following the workshop. So just to cover what we will be talking about today, I'll begin by briefly introducing the Living Windfarms project and giving a few updates before I will hand over to the Rich North Sea, who will be covering some of the latest research into benthic ecosystems and nature-inclusive design. And then after that, we will hand over to Thijs from Total Energies in the Netherlands. And Thijs will share some considerations for successful collaborations, lessons learned from pilot deployments, and monitoring results from our collaborative North Sea pilot deployment. Following this, we will have a presentation from Renska from Boskalis, who will share some of the considerations for deployments at different scale and for nature-inclusive design, as well as current challenges for contractors. After that, we will move on to the interactive session, during which we aim to conduct a SWOT analysis of different nature-inclusive design concepts before we open up the discussion, and people can ask any questions that they might have. Also, feel free to ask any questions in the chat throughout, and we can come back to these. So before we dive into the latest updates from the Living Windfarms project, I wanted to take us back to the reason for the project existing in the first place. So as we know, the North Sea holds huge potential for offshore wind energy. We've seen increasing amounts of wind farms being constructed, and many more sites and wind farms have been proposed in recent years. In order to reduce the impacts of erosion around offshore infrastructure, as I'm sure you all know, you need some sort of scour protection, and this will typically be in the form of rock armor or concrete scour protection. And where these materials have been introduced, we have noticed that there is this kind of reef effect for species that rely on hard substrate habitat, which is being created. And this is particularly important given the loss of hard substrate habitats in the North Sea over the last 100 to 200 years, including the estimated 90% of oyster reefs which have been lost. So that brings us onto the purpose of the Living Windfarms project, which is really focused on maximizing the reef effect that is being observed around the hard substrate scour protection, which has been introduced alongside the construction of offshore wind farms. So we wanted to optimize the design of scour protection without compromising the functionality and anti-scar properties, which of course is the whole reason why this hard substrate is there in the first place. So the Living Windfarms project is funded by the Offshore Wind Growth Partnership, and we've built a considerable network of project partners, including Total Energies in the Netherlands and the Rich North Sea, who we are fortunate enough to have joining us for the workshop today. And we're able to achieve the aims of the Living Windfarms project by working through the technology readiness levels. So from researching low carbon materials, understanding the science behind habitat and biodiversity provision, through to testing at a lab scale, understanding deployment and cost-effective production at scale, and finally, pilots in real-world settings. So throughout this process, engaging with industry and wider stakeholders to share knowledge and ideas is really important, and that is what we hope to do as part of this workshop. So what have we been able to develop as part of the project so far? We wanted to make our solutions compatible with conventional manufacture, transport and deployment methods, because we didn't want to add more complexity to an already complex process. So without going into too much detail, we have developed a range of nature inclusive solutions, and this includes our Exo reefs, which are full pipe deployable spheres, which form part of the armor layer around turbine foundations. We've also developed our Exo mats, which is our nature inclusive articulated concrete mattresses for cable protection. We've also got Exo Anchor, which are sinkers and clump weights, which create reefs as part of mooring systems. We've also got Exo Rock, which is nature inclusive rock armor for landfall infrastructure protection. We've got our Exo Lodge, which is a purpose-built standalone reef unit, which can target specific species. This has been designed to target Atlantic cod specifically. And we've also got our Exo Hub, which is our oyster reef designed to champion the ecosystem services provided by oysters, such as water filtration, whilst also creating reef habitats. And to briefly go over some of our pilot deployments, in September 2023, we deployed several of our concepts in the Celtic Sea in Wales at the Marine Energy Test Area offshore site. And these were recovered following an 18-month monitoring campaign where we used monitoring techniques such as ROV surveys, BROV surveys, and environmental DNA surveys as well to compare baseline biodiversity to post-deployment biodiversity value. And then in the North Sea, we currently have 5 of our Exo Lodge reef units, which were installed in July 2024. We will have some talks after this slide, which will go into a lot more detail on this. So hopefully that's brought everyone up to speed with the project and some of the things we'll be discussing today. So now I wanted to hand over to Thijs from Total Energies in the Netherlands.
Is my screen full screen now? My presentation. Can you hear me or not?
Yep, very
Okay.
good.
Excellent. Yes. My name is Thijs Kabel, and I'm the ecologist for Total Netherlands, and we conducted this artificial reef pilot at one of our platforms in the North Sea, mainly for 2 reasons. Of course, we were more interested in the effectiveness of nature inclusive design, but also if we could integrate these the installation and monitoring during our standard operations. Because what we see is, of course, that the nature inclusive design has great potential, but it can be very expensive and challenging to install. And we wanted to get hands-on experience if we could do this installation during our standard operations. And we identified that we had an opportunity because every year we do a yearly underwater inspection campaign that's to inspect our jackets, our pipelines, and we identified it as an opportunity to install and monitoring these review units. Because of course that makes logical sense. You already have a vessel deployment, you have the specialized equipment that you need, but of course something like that is always easier said than done, and we wanted to get that hands-on experience. So we did the installation last year during the pipeline inspection, and we used an ROV footage to take footage of the seabed to get a better understanding of how the seabed looks like before we install these artificial reef units. And what you can see here is a nice, quite a high abundance of different type of fish species. We see flatfish, we see the dragonet, we also can see some mullets in the footage. So, and also the seabed is quite typical for this area, sandy, but not a lot of sand waves, with a little bit of seashell intermingled between it. And yeah, we see also some juvenile pouting swimming around. So already the baseline already showed a pretty high abundance of different marine fish species. And what is also interesting is that we also noticed that there was some lobsters, and here we can see quite a large individual. And what was kind of funny is that he lost one of his claws, but that will grow back in time. And the second part of our inspection was looking at the jacket, because the jacket will tell us which species already live there. And because this platform has been in the water for around 30 years, so understanding which species already grow there gives an indication of what the additional value is of an NID measure. So we looked at the jacket at the similar height as the artificial units will be, so that we understand, okay, these species are already there. And then at the end project, we can evaluate, okay, what is now the additional value of these artificial? Do they bring something extra or not? And we see on this jacket growing, we have different type of anemones. We have sponges, we have some barnacles, we have swimming crabs. We see different type of some worms. So it's a pretty mature and diverse benthic marine growth community. And it's not in this footage, but we also found some soft corals, deadman hens on the jacket. So there's a pretty good indication that this is a quite mature marine growth community. And then we start this year again with doing the same inspection, doing the same inspection campaign, only of course a year later, we did the baseline survey of the artificial reef units. And what you can see here is quite a large school of pouting and also some whiting intermingled between it. And you can see that there's quite a significant abundance of these fishes schooling around this artificial reef unit. And these are quite typical species that are associated with hard substrate reefs in the Dutch North Sea. But it's also interesting that you can see at the ceiling of in the side tunnel, you can already see some marine growth developing. And this is without the use of any bait. This is just lowering down the ROV in front of the artificial reef units and record it. So we didn't use any bait to attract more fishes. And here you can see inside the tube, you can see they really utilize the whole artificial reef unit. They swim through the tunnel, they go to the side panels, and you can see there's quite a lot of already some barnacle-like marine growth developing inside the tube. And what you can also see is at the seabed, there's some shell material, some shells from snails accumulating. So for something that's already only been there for 1 year, we can already see some nice marine growth developing, which is a positive sign. And here we have a topside view, and what you can see that the reef units are actually quite popular with brown crabs or edible crabs. And you can see that the swirly wooden elements already also quite covered with barnacles. And also under the metal bars, you also see some swimming crabs. And now in front view is the removable reef plug. That is a unit that can be retrieved to do taxonomic analysis of the marine growth. And we use the ROV to bring this up to the surface and send it to a lab for analysis. So we provided the contractor who did the service with the container and also the PPE, because the reef plug had to be stored in formaldehyde to preserve it good enough. And here you can see this is the control unit that we use for this. This is a more simplified artificial reef. So it's basically just a slab of concrete, and we want to see does these specifically designed units like the Exo, is it worth the additional investment, or is something simple like this already good enough to increase the biodiversity? Because here we see again the same attraction by these poutings. We can also see some marine growth developing. So we'll have to see, but by the end of the project, we hopefully know the added value of such a specific design like the Exo lords. And here you can see the reef plug that has been pulled up with the ROV. You can already see there's quite some nice marine growth developing, and we had this marine growth analyzed in a lab by a taxonomic expert, and then you get a very long list of species that has been observed on this reef plug. The dimensions of this reef plug were about a width of 18 centimeters and about 30 centimeters high. And in total, we have about 40 species growing on this reef plug. And to put it in perspective, when we look at hard substrate sampling in the North Sea, we see that the species richness varies between 20 and 60 species. And this reef unit with the reef plug has only been in the water for 1 year. So already having 40 species, I think, is pretty nice. Of course, it helps that it's been placed so close to the platform, which will probably be a very important source of biocolonization. And what we see is that we have a quite diverse range of species. We have some barnacles, we have some amphibians, we have bivalves, crustaceans, slugs, different type of worms, sea anemones, and I want to highlight a few species. We can really see a high abundance of barnacles, about more than 500 individuals on this plug. What is also an important species is the Sabellaria spinellosa, which is an important spotted species in the Netherlands because it's a worm that can form reef-like structures in sandy habitat. So it's been a real focus on restoration and also nature includes design measures in Dutch ecology, offshore wind tenders with ecology criteria, who want the bidders to take measures to monitor or improve the ecological functioning of the Sabellaria within offshore wind farms. So it's a very relevant species. So it's very interesting to see the species on this artificial reef unit. What I also found interesting is that we have more than 700 of these tiny little crabs. So these are a type of porcelain crabs, and they can have about the body is only a max size of 1 centimeter. So I find it quite interesting that there are so many crabs on this reef unit. I think it shows that this little ecosystem can be quite productive, and I think this later on this species can probably become an important food source for other species. So I think these are positive development. Yeah. For us, the main takeaways was we were able to do this installation and monitoring during our yearly underwater inspection, meaning that we were able to do it efficiently and with reducing cost. And from the ecological point of view, we saw a lot of pouting congregating around the Exo lodges. The reef plug revival was a success. We were able to successfully pull it up from the seabed, store it, and ship it off to the lab for analysis. And what we also noticed, both in the brown crab, but also in these tiny porcelain crab, we saw a high amount of abundance of these crabs. So I thank you for the attention and give the floor to the next speaker. And if you have any questions, you can put them in the chat.
Thank you for that, Thijs. That was fantastic. If we could pass over to Elina now to share some of the latest findings in nature inclusive design. Thanks, Elina.
Thank you. And hi, everyone. It's so good that you're here. My name is Eline van Onselen. I'm a marine ecologist and I work for the Rich North Sea program. And today I'll be talking a little bit about the principles behind nature inclusive design and give you an example of one of the projects we're working on right now. So let's dive in. And maybe you've seen these pictures before, but I always want to rub them in a little bit because this is why we do it. In the Dutch North Sea, there used to be 30% of the seafloor used to be covered in reefs. And this is something that we tend to forget because our current seafloor is a sandy habitat, and that has worth in itself, but it used to be very different. And because we like to eat oysters and they don't swim away, it was relatively easy to fish them out. And now the entire habitat is actually collapsed, which is a shame because oysters and reefs, they add so much to the habitat. Reefs are really like little oases in the desert. There's a lot of species that benefit from it. And oysters are just these species which are for us very easy to focus on because they are obvious reef builders, they're water filters, and they're also relatively easy to breed. So we can breed them in hatcheries. Now that's why we do it, but how do we do it? That is, of course, the question. We want to bend the curve. So we used to have a sea full of life. Right now, marine biodiversity is falling and intervention is really needed. And with the Rich North Sea program, which started in 2019, we thought, okay, we see this development going of offshore wind. And we think this is really an opportunity for nature because inside offshore wind farms, most of the times, no other activities are allowed. In the Netherlands so far, bottom trawling, for example, is not allowed. Sand extraction is not allowed. Any type of oil and gas extraction is not allowed. And this really gives the opportunity for nature to recover. However, if we do nothing and just let nature take its course, it will take decades before something will start to grow. And in the case of flat oyster, for example, those larvae, they don't travel very far. So it will take them a very, very, very long time to get into a wind farm if we don't seed them, for example. So that's what we've been doing since 2019. We had the official kickoff of the program in 2020, so it's already 5 years. We've been working in offshore wind farms. And what makes our program unique is that we sought to participate and cooperate with offshore wind farms and offshore wind farm developers. And there was a lot of commitment there and a lot of enthusiasm because they all wanted to work together with us. And we think that's really a difference from what it was, for example, 10 years ago when nature was always sort of an afterthought. And here on this image, you can see some of our projects, which you can also find in our toolbox, which I will mention again later. And of course, because an image says so much more than just words on the slide, here's some images of our projects from the past 5 years. Here on the top left, I'll start with a loose oyster with a tracker on it. And this was deployed in the Gemini wind farm where we experimented with loose oysters on substrate. Next to it, there's an image of oysters in cages on a structure, which were deployed in the Borselen wind farm in the Netherlands. And this was one of the first iterations of our broodstock structures that Van Oort actually designed. And these work really well so far. The only downside of having a cage is that there's a lot of fouling going on. So you have to clean them or have large enough holes for water to keep flowing through. But the bigger the hole in your cage, the bigger the chance of predators coming in and eating your oysters. So, but so far these have worked really well, and we found small oysters in the cages, but also outside of them. So that's really good news. And then next to that, on the top right, there's an example of an artificial reef that we deployed in our offshore test site, where you see a lot of marine growth. It's quite similar to what Thijs showed earlier. There's just a lot of colonization going on, and as soon as you drop a camera or a diver in this case, there's pouting, for example, schools of them, which is always a really nice sight to behold. Then on the bottom left, there's again an oyster broodstock structure with adult oysters glued to these poles. And these were deployed in the Luchterduinen wind farm in the Netherlands. And then in the middle, there's a nice cod. We also did some experiments where we tagged cod to see what they are doing in the wind farm. There were artificial reefs deployed in Borselen as well, but in the Ørsted part. And we tracked them to see what they were doing together with lobsters as well. And on the far right in the corner, there's a nice small ROV, because of course we have to monitor our project as well. So we've been experimenting for the last 5 years, but so far really large-scale nature restoration projects in wind farms are not there yet. So what's holding us back? I'd like to put some time into this because I think this is really important to highlight. The first one is the shifting baseline syndrome, because our baseline is different from that of our parents, of their parents, and so on. If we go back in time, would be really nice, and we go back to the 16th century, and we would sit on a dune in the Netherlands, in Scheveningen, for example. In spring, there would be whales migrating the coast. And this is something we cannot imagine anymore. Really, our baseline has shifted. Large species like bluefin tuna, like the large common skate, which is not as common anymore, like large shark species, they have all disappeared from our seas, and we almost can't imagine them being there anymore. And this shifting baseline syndrome really is a problem because we base our legislation and our policy on our own baseline. So as far back as we can imagine it to go back, and sometimes not even that far. And that's also, it's actually the third point in this list, where policy is made for industry. So it's based on a shifting baseline, but it's also not made for nature restoration. So I can give you an example of this. We were trying to place living oysters in a wind farm, and we actually needed a fisheries permit for this. Even though we were not taking them out, we were placing them in the water, but we still needed this permit. And sometimes rules like this will really hold us back. And then I skipped the second point, which is multi-use, because right now we're looking at having multiple uses in one area. So for example, in a wind farm, we want nature restoration, but maybe we also want fisheries. Maybe we also want floating solar panels. Maybe we want to look at different types of energy conduction. And this all takes up a lot of space. And having multiple purposes in one area is holding us back in creating large-scale nature restoration projects. Because if we want to do nature restoration, but there's also a fisheries presence, then maybe, doing both at the same time is not very beneficial. Then we'll go to the fourth point, which is our capitalistic approach. And people oftentimes have asked me, what is your business case? What is the business case of your program? And we don't really have a business case. Our business case is nature. And of course, you can put a monetary value on nature. You always can. But having the intrinsic value there and just knowing that nature restoration but also the survival of specific species is important. You cannot put this into monetary values. And our current systems are not built for that. And that's also part of the short-term thinking that we're used to. So our economy, our policy, our whole political system is based on short-term thinking. And if we look at proper nature restoration, this takes decades, maybe even longer, for a system to really restore itself. And then, of course, the policy that we do have, if we want to change that, that's quite difficult. It's inflexible. It's quite slow to adjust. And this sometimes really can hold us back. Okay, I hope this isn't a too depressing view, because not all of it is bad, of course, and we're working on it. And having had 5 different offshore projects in the last 5 years really shows that it is possible and that people are willing to make a difference. So we're still hopeful. So I'll let you in on some cool projects that we've been doing. First being the Exo project, and the second one being part of the nature regeneration program for the North Sea. The first one, the Exo project. Exo stands for Remote Setting of Flat Oyster. I've shown you some pictures before of adult oysters being glued on structures or being put into baskets and placed in offshore wind farms. And this, of course, is a really nice idea because adult oysters are ready to reproduce. So if you place them in the water and they start reproducing, then they're able to, in theory, make a reef. But if you want to create an actual reef, you're going to need thousands upon thousands of oysters. And it's going to take a while. If you only place 4 of those broodstock structures with maybe 5,000 or 8,000 adult oysters, it's going to take a long time before you create an actual reef. So we need strength in numbers. And we simply do not have enough adult oysters because it's a species that has collapsed. So we cannot harvest them from the wild. And our hatchery capacity is also quite limited if you're talking about adult oysters. So we could possibly buy some from abroad, but then you're also mixing your genetics, and we really don't know what that's going to do. So we thought about this project in a way that we want to scale up. And a way to do that is work with spat. And spat are the baby oysters that have just settled. So a flat oyster reproduces by sending out seeds, the male, and then the female takes the seeds in and then pushes out the larvae when they've I can't think of the word, but the larvae come into the water column and they float around for about a week before settling. And remote settling basically means that you transport the larvae to a specific location. And in this case, we created containers using rocks, and those rocks can be used, for example, as scour protection. And those containers with rocks are filled with seawater, and then the larvae of those oysters are released into this container. And after a few days or after a week, they will settle on the rocks, and then you can place the rocks anywhere you want. And really, the main advantage of this in comparison to the adult oysters is that you can transport thousands or even millions of larvae because they are tiny. It's very cheap to transport them, and it's very easy to place them in the water, and they will settle on their own. And then you can place the rocks in a place that you think is a good place. So, for example, now these rocks for this project have been placed in the Rotterdam harbor. And on the longer term, our partner TenneT, so the Dutch TSO, will place them on cable crossings. And in this way, it's really easy to scale up. So you have to hurry up a little bit. I'm always talking too much. So a quick recap of the Nature Regeneration North Sea program. This is a program from the Dutch ministry. And there's quite a lot of money available until 2030 for a large rollout of nature restoration in the Dutch North Sea. This is broader than just offshore wind. and the goal is really to strengthen nature and to have a balanced ecosystem once more. The program is divided into sub-programs: learning by doing, upscaling, monitoring, international, and everyone participates. And right now, an alliance containing government and other stakeholders are forming the program, and hopefully the first large-scale projects will be in the water in the coming years. Of course, if you want to know more about our project, visit the toolbox. There's a link on this page. I can also put it in the chat if you want after my talk. And if you have a really cool project in offshore wind farms concerning nature restoration, please add your own project to the toolbox as well. Thank you so much, and I'll give the floor back to the next presenter.
Thank you, Alina. And I really recommend checking out the North Sea Toolbox if you haven't already. It's got some really great initiatives on there. If I could hand over to Renska from Boskalis for the next presentation, that would be fantastic. Thanks, Renska.
No worries. Can you see my screen?
Yeah, all good.
Well, good afternoon, everyone. Thanks for inviting me to give a little talk on the contractor's perspective of biodiversity restoration offshore. I'm Renske, as I said. I'm an environmental engineer at Boskalis, and Boskalis is a contractor, and we're active in multiple disciplines, from offshore wind to coastal protection to salvage. And company-wide, we have our biodiversity framework, of which the Artificial Reefs program is one of the pillars. And in a team of 3, we manage projects relating to restoring marine habitats that require mainly substrate, which can range from very small degradable units to really massive concrete blocks and actually everything in between. And within our team, we have our specific focus areas, and mine are oyster restoration and biodiversity monitoring. And when we're focusing at marine habitat restoration in the offshore North Sea, we as a contractor, we're mostly active in the rock installation scope, as Alina already touched upon. And this is done through our seabed intervention department. We have large SRI vessels, and with those we install rock as part of the scour protection, both around monopiles and cable crossings. And these vessels are also capable of installing any other substrate, such as artificial reefs, either through the inclined fall pipe or with a grab at shallower depths. And currently the marine habitat restoration is done on a pilot and a small scale, but as Elina also already said, we really need to scale up because we have to make impact to really contribute to biodiversity restoration. And with our large vessels and our already planned activities offshore, so mainly the rock scopes, we have the opportunity to do so and make upscaling efforts feasible by aiming to keep additional costs low and time reduced. And in this short talk, I will just touch upon how those vessels work, questions we have to answer, and challenges we face from a contractor's perspective. So here you can see one of our subsea rock installation vessels. And in principle, an SRI vessel transports rock from the quarry location to the offshore location and installs it via its inclined fall pipe, which you see here. And to reduce price and carbon footprint, loading and sailing should be as efficient as can be. Well, then in a traditional scope, the vessel just loads at a location and sails directly to the project site. If artificial reefs or rock with spat are added on top of the scour, this requires rerouting. To make it feasible, loading locations of both rocks and reefs should be nearby to each other. And then the next step is the loading itself, which should be efficiently done, but it also depends on the type of reefs that we're using. Can it be done by bulk, by a crane or a grab, or does it have to be done per individual unit, or are they all stored in a container? Then, of course, the design and the dimension of the units itself determine how many reefs fit into the vessel, and thus the number of trips that are needed to place them. And of course, the more trips, the longer it takes, so the higher the carbon footprint and the higher the costs. And the installation of the units itself should be timed in such a manner that it fits into the entire scope. So if the reefs are placed on as a top layer of the scour, how does it fit in the complete context of the wind park? And then we come to the final step, which is the installation itself of the reefs. And this is actually quite easily done, especially when it's done through a fall pipe. Now, all these considerations together are essential information which we need at an early stage in a tender or a project, because logistics and locations are the key to reducing time, carbon, and costs over the whole artificial reef scope. And as you can imagine, the size of your vessel links directly to the number of reefs that can be transported per trip. And as contractor, therefore, it's wise to invest in larger vessels. And luckily, we're building the largest SRI vessel of its kind, called the Windpiper, which can come in handy for upscaling artificial reef placement in the offshore environment and keeping the carbon footprint low. So through the use of our large vessels and the transportation and installation of reefs, the contractor is actually the bridge between reef suppliers and offshore developers. And this provides the contractor with the opportunity to upscale. And the considerations I just mentioned and those challenges are easily overcome through our experience and expertise with large projects in diverse environments. And we can provide advice and the equipment for scaling up. But then we come to what is actually the biggest challenge for a contractor, and it's also being that bridge, because scalability also means large-scale production of the reef units at a suitable location with the proper materials. And then those units have to be transported to a location for stockpiling, and then they have to be loaded efficiently at the right time with the right equipment to make sure that the units are installed at the correct location in the entire workscape. So as a contractor, you're dependent on the upscaling capabilities of other parties, for example, reef suppliers. And when we're looking at living organisms, as Alina just mentioned, another dimension of uncertainties and logistical challenges is added because you're working with live organism, and it increases the logistical complexity, both on a geospatial level, but also on a stakeholder level. And as the SRI vessels will have to change its logistical procedure compared to when you're using a scope with only rocks, the whole artificial reef scope will increase the time and the costs of the total project. And it is upon the developer of an offshore wind farm to assess how much of these uncertainties and costs they also make available for the installation of the reefs for marine habitat restoration. So it's essential to show the importance and provide proof or some kind of quantification of the added value of biodiversity compared to rocks to also the developers, because in the end, the developer decides. And this is a challenge because in this position of the contractor in the larger scheme of an offshore project, it does link to the biggest opportunity that we have for upscaling, but it also links to our largest challenge: who's responsible? And to answer this and other considerations, we need early involvement of contractors and actually all stakeholders in a project. So from a contractor's perspective, we should, and we do want to play a role in restoring the marine habitat. And as the biodiversity has shrunk so much and our oceans are struggling to stay alive, we should really restore at a large scale. And through our experience with large projects, we can help to mature innovative ideas and turn concepts into really feasible products that can be installed offshore. And we can connect all parties, innovators to hatcheries, governments and developers and scientists. And there are really great initiatives out there, but we have to work together to make real impact for the environment and marine biodiversity. And with this, I want to end this short talk by asking you to connect, to tackle challenges together, and also to collaborate early on in the process, because we really need truly feasible and scalable solutions to make an impact on a large scale and not only on pilot scale. And here's a final picture of Sabellaria, one of the target species on the North Sea. So thank you for listening, and I really look forward to the SWOT analysis.
Thank you, Renska. That was very insightful, and yeah, I think you're definitely right. Collaboration is essential for kind of making sure that these nature inclusive solutions can be deployed large scale. That leads us nicely onto the interactive portion of today's workshop and the SWOT analysis. Bear with me a second while I find my slides. So in the SWOT analysis today, what we hope to do is kind of evaluate 5 different types of nature inclusive designs which can be used within offshore wind. So for those who haven't conducted a SWOT analysis before, this involves looking at the strengths, weaknesses, opportunities, and threats. And the strengths and weaknesses are typically determined by internal factors which are within an organization's control, whereas threats and opportunities are typically outside of an organization's control and influenced by external factors. A SWOT analysis is also most beneficial, of course, when we consider multiple perspectives. So that's what we're aiming to do as part of these workshops, get perspectives from different groups of stakeholders and kind of combine these to see if there's kind of variations and make sure we all kind of have a mutual understanding of what needs to be done in order to scale up nature inclusive design. We do hope to share these after the sessions in a final workshop as well, where we invite all of the attendees back. So of course we want the contractor's point of view for the SWOT analysis, and it will focus on interventions in a broad sense as opposed to the solutions developed by Exo Engineering. So we wish to focus on nature inclusive turbine scour protection, so the armor layer around turbine foundations. We also want to focus on nature inclusive cable scour mattresses, conventional concrete articulated mattresses with surface textures and features deployed using conventional methods. We also want to look at standalone artificial reefs, so large reef units such as the ones we deployed in the North Sea with these large habitat features. And then we also want to consider add-on nurseries, so kind of mesh cages fixed to turbines close to or at the surface. And finally, oyster restoration using pre-seeded substrates. So what I hope to do now is invite you over to join us on Mentimeter. There's a few ways you can do this. You can either go to mentimeter.com and type in the code, or scan the QR code, which I'm hoping will take you to the right place. I'll just give people a few moments to join us over on Menti. So I'm just going to switch over to the Menti screen now. I believe the code has been put in the chat as well, if people still need that. So hopefully people have been able to get in okay. I can see we've got 14 people who've been able to join us on there, so that's fantastic. So bear with me. Okay, so hang on one moment. What's going on here? There we are. Okay. So just out of curiosity, I wanted to see how many people we have along today have actually done a SWOT analysis before. Okay, we've got lots of yeses. That's fantastic. Perfect. Okay, I just wanted to explain before we start as well. I have grouped the SWOT analysis, the strengths, weaknesses, opportunities and threats together for each type of solution. So if I move on to the first slide, if you're contributing a strength, just put kind of an S with a colon or a dash before it, and the same for weakness with a W, and so on for the opportunities and threats. So I really wanted to kind of get an idea of, sorry, bear with me, it's gone back, of what people's perceptions are of nature inclusive turbine scour protection, so that kind of nature inclusive armor layer around the base of offshore wind turbines in terms of the strengths, weaknesses, opportunities, and threats. Perfect. We've got some answers coming through. One of the strengths, multi-use. Definitely combining different approaches for maximized benefits. We've got scalable as well. Less additional material for reef scope. Definitely combining these two approaches. Got a weakness here as well. Extra expense. I think that's definitely something that needs to be considered. Got lots of strengths coming in. Kickstart new populations of focus species. Potentially full pipe deployable. Spillover effects. Enhancing biodiversity and habitat creation. Opportunity here, creating stepping stones in a large area. I think that's a really important one as well. A weakness here that I expected to see, decommissioning. That's kind of a hot topic for how we move forward with nature inclusive design. Fantastic. We've got some great responses coming through. I'll just give people a few more moments in case they've got anything else. And then I'll move on to the next nature inclusive solution. Lots of opportunities coming in. Same monitoring methods between offshore wind farms with nature inclusive design. Scour. No additional space or requirement to determine location necessary. Interconnectivity again. A weakness stability tests required. Of course, we need to make sure that functionality and stability is not compromised as a result of incorporating nature inclusive design. Fantastic. We've had some great responses there. And I'm going to move on to our next nature inclusive design, which is nature inclusive cable scour mattresses. So same as before, I invite you to contribute any strengths, weaknesses, opportunities, and threats you can think of when it comes to nature inclusive cable scour mattresses. Got a couple of responses coming in now. We've got one strength, scalable, and a weakness, deployment with a question mark. I imagine that's kind of getting at Are there any additional considerations when deploying nature inclusive cable scour mattresses? How does it work when cable needs maintenance? It's a key point to think about as well. Of course, if we then need to take up the nature inclusive cable scour mattress, is that going to disrupt the reef that we've potentially created? Decommissioning again as one of the weaknesses. We've had a couple of threats as well. Limited effectiveness in case of sand waves. And biodiversity benefits likely very location dependent, e.g. seabed type. Yeah, definitely. How to attract target species as a weakness. All important considerations. I'll just give a few more moments for any last thoughts, and then I will move on to the next nature inclusive solution. Okay, if I move on to the next one, something a little bit different here. We're looking for the strengths, weaknesses, opportunities, and threats regarding standalone artificial reefs. So independent of the scour, no anti-scour properties, just kind of placed standalone on the seabed. Had a weakness already, difficult to scale up. I suppose as well, some of the strengths for the previous designs kind of being integrated into the scour protection itself could be a weakness for this design. You need to kind of consider an additional unit as opposed to kind of two units combined together, achieving the anti-scour properties and the nature provision in one. And a couple threats coming through as well. No proven standard design, one size fits all approach yet. And additional permits might be required. Yeah, that's exactly it. Opportunity biodegradable. Having something that kind of degrades over time. Once perhaps you've been able to establish a naturally sufficient reef system. It's a great opportunity, that one. Weakness more costly. Yeah, I would agree with that one. And additional locations and units, so added materials and trips. Snagging risk of bottom trawlers as a threat there. Still lots to learn about effectiveness of different designs, sizes of the materials. Just give a few more moments for any last thoughts. Decommissioning again as a threat. Fantastic. I'll move on. Just two more left. Same again, but this time thinking about turbine add-on nurseries, independent of the seabed, kind of attached to the actual turbine itself. I suppose one that immediately jumps out is this can be applied for floating offshore wind. There's a strong opportunity for that. easy to monitor during maintenance as one of the strengths has been contributed. Got additional engineering required as one of the weaknesses as well. Yeah, I think we definitely need to consider kind of the effects of drag, potentially turbine fatigue. Another strength coming in, installation combined with turbine installation. Yeah, I suppose if you, in the design stages, know you're going to be attaching units like this onto the turbine, you can think ahead and try and make your life easier further down the line. We've also got a couple of threats that have been contributed. Biofouling, of course, a big problem. Attraction of marine birds that are at risk of collision with turbines. That's a very interesting one. I hadn't even thought of that one. Might negatively impact monopile installation. Introducing additional considerations. Okay, I'm going to move on to the final approach, which is oyster restoration. So a little bit different from the other ones. We would love to hear your thoughts on the strengths, weaknesses, opportunities, and threats for oyster restoration. And then after this, we will open up the discussion, give everyone a chance to ask any questions that they might have. I suppose some of the aspects have been covered by Alina in her discussion. We've not got natural reef systems which exist where we can just, take a few oysters and move them to the site that we hope to kind of do oyster restoration in. And the capacities, the hatcheries are at capacity as well, which of course is a challenge when thinking about oyster restoration. Got a strength here, no need for decommissioning. And another strength, remote setting provides for scalable and feasible upscaling. Definitely. And a threat, parasites. Of course, when we're working with live populations, it's a key consideration. Another strength, native species, reef builder, water filterer. Definitely. And an opportunity here, build an ecosystem from the ground up. Okay, I'll just give everyone a few more minutes in case we've got any last thoughts, and then I will move on to the open discussion. Another weakness just come through, only one species, so should be combined with ecosystem restoration. It's in disease as another weakness. And I'll finish off with this one as a strength, work together with industry for a stronger ecosystem. I think that finishes us off nicely. Kind of overarching idea behind the workshop is, encouraging that collaboration so we can restore nature and not make each other's lives harder. Okay, thank you everyone who contributed to that That's been incredibly helpful. And as I say, there'll be a final workshop where we hope to bring everybody back together and kind of share the different perspectives on the different kind of opportunities for restoring nature. So I'll stop sharing that now. So now it's time for the open discussion. Has anybody got any questions? Has anything been asked in the chat? If anyone would like to contribute to that. Yeah, I've got a question just come into the chat. Hello, thank you very much for your insightful presentations. Thank you. This project is on wind installments, but I was wondering if you are aware of nature inclusive design case studies on oil and gas platforms and or CCS.
I think I can take that one. Of course, the pilot results that I'm presenting were at a gas platform in the North Sea, and I'm also involved with the Aramis CCS project, and we will also be implementing nature inclusive design measures. But of course, the offshore wind development is ahead of us, so it's still a relatively developing field, and it was somewhat also challenging during the process of translating those NID measures for CCS and suitable for a near a platform. So it's definitely something that's happening. I think mainly for CCS, because there's, at least for us in TotalEnergies, we're not developing any new gas extraction in the North Sea, but we will have some CCS plants in the pipeline, and there we'll be applying nature inclusive design. We're thinking about nature inclusive mattresses. We're working on biodegradable tree reefs. So we're definitely some interesting projects in the pipeline with NID and CCS.
Thank you, Thijs. That's great. Has anybody got any other questions? Feel free to also unmute yourselves if you'd prefer to ask it that way. Okay, I will give a few more moments just in case anybody's busy typing away in the chat to ask any more questions. But if no one else has any more questions, I just wanted to say thank you to everyone for joining today. It's been great to have you here and to get your perspectives on different types of nature inclusive design within offshore wind. I think there's a lot of potential there, and it's just got to emphasis on the collaboration side of things to kind of push these designs forward and make it easiest for everybody.
Yeah.
Also, thank you to our presenters for sharing today and your insightful presentations. And the workshop has been recorded, so we will be distributing the link out to those who signed up. So you should receive that link in an email later this week. And as I mentioned earlier, we also hope to host a final workshop where we will be bringing everybody back together to hopefully kind of continue those conversations around nature inclusive design. Yeah, I hope you've enjoyed this workshop, and hopefully we will see you at the next one. Thanks, everybody.
Thank you very much for the
Bye.
talks. Thanks, Jeff.
Have a nice day.
Have a nice day.